Hello there, and welcome to this sleepy universe zone. The universe is filled with more light than your mind can comprehend. And yet, when you look up at the night sky, you see almost nothing. Not dimness, not a faint glow, but overwhelming absolute darkness. And that is the problem. Because if the universe truly works the way physics says it does, that darkness should not be there at all. Every direction you look should end in light. Every patch of sky should shine with the surface brightness of a star. The entire sky should be blazing, edge to edge, like the surface of the sun. But it isn't. It's black. Deep, silent, dominant black. And that contradiction is not a small detail. It is one of the most disturbing clues about the true nature of reality. You've seen it your entire life, and you've never questioned it. The darkness between the stars feels normal, obvious, almost comforting. But what if that familiarity is misleading you? What if the most ordinary thing you experience every night is actually one of the biggest unsolved tensions in how the universe should behave versus how it actually behaves? Because the truth is, the darkness is not just empty space. It is evidence that something about the universe is fundamentally different from what your intuition expects. And this video is for you, whether you've ever thought about this before or not. Because once you begin to see it clearly, you won't be able to unsee it. The night sky will stop feeling simple. It will stop feeling passive. It will start to feel like a message. Quiet, constant, and impossible to ignore. A message about distance, about time, about the limits of light itself, and more importantly, about why the universe, despite containing unimaginable fire, still loses to darkness. So why should you keep listening? Because by the end of this journey, you will understand something that most people never fully grasp. Not just why space is dark, but why it has to be dark. Why even trillions upon trillions of stars are not enough. And why the darkness you see is not a temporary condition waiting to be filled, but the natural outcome of the laws that govern everything. If this kind of quiet exploration helps you relax, helps your thoughts slow down, or simply gives you a different way to feel the universe around you, consider leaving a like so this video can reach others who might need the same calm moment. Now, let's begin with the core idea. Imagine a universe that stretches infinitely in every direction, filled more or less evenly with stars, not clustered in one place, not empty in another, but distributed throughout all of space. Now pick any direction, any tiny point in the sky, and draw a line outward from your eyes into the distance. If the universe is infinite and filled with stars, that line must eventually hit one. Maybe not nearby, maybe not even within your galaxy, but somewhere, at some distance, there must be a star along that line. And here is where things become unsettling. Because if every single line of sight ends on a star, then every part of the sky should be bright. Not partially, not occasionally, completely. The darkness should vanish entirely. The sky should glow with a continuous, uniform brightness, as if you were staring at an endless wall of stars layered behind one another. But that is not what you see. Instead, you see gaps, vast, dominant regions of blackness that swallow almost everything. The stars are scattered, isolated, separated by enormous stretches of empty darkness. And those dark regions are not small. They are not rare. they are the majority of what you see. So something is wrong. Either our assumptions about the universe are incomplete, or something deeper is happening, something that prevents light from ever filling the space the way it should. And that is exactly what we are going to uncover. Because the answer is not simple. It is not just distance. It is not just dimness. It is not something you can explain away with a single idea. And it is a combination of multiple fundamental truths about reality itself. Truths about the age of the universe, the speed of light, the expansion of space, and the overwhelming geometry of emptiness. Each one adds another layer to the darkness. Each one makes it deeper. And together, they reveal a universe that is far stranger than it first appears. So as you settle in, let your breathing slow and let your mind drift gently with the rhythm of these ideas. We are going to move step by step through this paradox, not in a rush, not with pressure, but slowly, calmly, the way understanding is meant to unfold. Because the darkness above you is not just a background, it is the main story, and it has been waiting for you to notice it your entire life. If the universe were infinite, eternal, and filled with stars, the night sky would not be dark. It would be unbearable, not dim, not softly glowing, but overwhelmingly, inescapably bright. And this is not a poetic exaggeration. It is a direct consequence of geometry and the way light behaves across space. Because once you follow the logic carefully, the darkness you see every night begins to feel like something that should not exist at all. Something that contradicts the very structure of the universe as we first imagine it. And the argument itself is almost disturbingly simple. Imagine you are standing at the center of a vast universe, one that stretches endlessly in every direction. And instead of thinking about individual stars, imagine that space is divided into thin spherical shells around you, each shell representing all the stars at a certain distance. The first shell close to you contains a relatively small number of stars. The next shell farther away contains more, and as you continue outward, each shell becomes larger and larger. In fact, the volume of each shell increases with the square of the distance, meaning a shell twice as far away contains 4 times as many stars. A shell 10 times farther away contains 100 times as many stars. And at first, this seems like it should make the sky brighter the farther out you look. But then something unexpected happens. Each individual star becomes dimmer with distance, and it does so in exactly the same way. Its brightness decreases with the square of the distance. So a star twice as far away appears 4 times dimmer. A star 10 times farther away appears 100 times dimmer. And now you begin to see the strange balance forming. More stars in each distant shell, but each one proportionally dimmer. And the two effects cancel perfectly. Every shell, regardless of how far away it is, contributes the same total amount of light to your eyes. The nearby stars contribute a certain brightness. The stars thousands of light years away contribute the same amount. The stars billions of light years away contribute the same amount. And if the universe truly extends infinitely, then there are infinitely many such shells, each adding the same contribution. And when you add an infinite number of equal contributions, the result is not finite, it is infinite. The sky should not just glow, it should blaze. Every direction you look should eventually end on the surface of a star. Every patch of sky should be filled, not with darkness, but with light stacked upon light across unimaginable distances. The entire sky should resemble a continuous, radiant surface as bright as the average stellar surface temperature, like being surrounded in every direction by the surface of the sun. There should be no night, no gaps, no blackness at all. And yet, when you step outside and look up, that is not what you see. Instead, you see darkness dominating everything, vast regions of empty blackness between isolated points of light. And those dark regions are not small or rare. They are the majority. The stars are scattered, separated, surrounded by an overwhelming void that seems to contradict everything. This simple geometric reasoning predicts, and this is where the discomfort begins, because the logic is not flawed. It is not speculative. It is based on fundamental principles like the inverse square law. Principles that have been tested in countless ways and applied across all of physics. And still, the conclusion does not match reality. You can verify it yourself without any instruments at all. The sky is dark, undeniably, overwhelmingly dark. So something in the assumptions must be wrong. And for a long time, it was tempting to believe the explanation was simple. Perhaps stars are just too far away. Perhaps their light fades into nothing before reaching us. It feels intuitive. The farther something is, the dimmer it becomes. Eventually, it should disappear. But as the shell argument reveals, this intuition does not hold, because distance alone does not reduce the total light reaching you. It only redistributes it. What you lose in brightness per star, you gain in the sheer number of stars. The total never decreases. It remains constant shell after shell, so the darkness cannot be explained by distance alone. Then another idea emerges. Perhaps something is blocking the light. Perhaps interstellar dust or gas absorbs it before it reaches us. And again, this seems reasonable. We see clouds block sunlight on Earth all the time. But in space, this reasoning collapses, because any material that absorbs light will heat up. And once it heats up, it will begin to radiate its own light, eventually reaching a balance where it emits as much as it absorbs. So instead of removing light from the sky, it simply becomes another source of it. You cannot hide light by placing obstacles in its path. You only transform the path it takes. And so this explanation fails as well. And now, the realization begins to take shape. The darkness is not caused by something simple. It is not distance. It is not obstruction. It is not a lack of stars. It is something deeper, something structural, something built into the nature of the universe itself. Because for the sky to remain dark, at least one of the assumptions behind this infinite brightness must be wrong. Perhaps the universe is not infinite. Perhaps it has not existed forever. Perhaps stars are not distributed the way we imagine. Or perhaps all of these assumptions are incomplete. And as you continue listening, you will begin to see that the answer is not just one of these ideas, but all of them working together, each one removing a piece of the expected brightness, each one deepening the darkness, until what remains is the quiet, vast, familiar night sky above you. A sky that looks simple, but is in fact revealing something far more profound than it first appears. The sky is dark for a reason, and the first crack in the logic of infinite brightness comes from something deceptively simple, something so fundamental that it reshapes everything that came before it. The universe has not existed forever. It had a beginning, and that single fact quietly dismantles the entire expectation that the sky should be filled with light, because the original argument assumes something critical, that stars have been shining for an infinite amount of time, that every photon ever emitted has had unlimited time to travel, to spread, to fill every possible line of sight. But reality imposes a hard limit, a beginning approximately 13.8 billion years ago. And that limit changes everything. Because light, despite being the fastest thing in the universe, still takes time to travel. It does not appear everywhere instantly. It moves, it crosses distance. And if the universe has only existed for a finite amount of time, then light from the most distant regions has not had enough time to reach us yet. And this creates something profound, a horizon, not a physical wall, not an edge in space, but a boundary defined by time itself. Beyond a certain distance, the light simply has not arrived. Those stars may exist. Entire galaxies may be burning with unimaginable energy, but their photons are still in transit, still traveling through space, still on their way. And until they arrive, they contribute nothing to the brightness of our sky. They are invisible, completely and permanently invisible from our perspective. And this means the universe we can see, the observable universe, is not the entire universe. It is only the portion from which light has had time to reach us since the beginning, a sphere centered on us with a radius determined by the age of the cosmos and the speed of light. And within this sphere, there are billions of galaxies, trillions even. But beyond it, there could be infinitely more. And none of them matter to what we see, because their light has not had enough time to get here. And suddenly, the shell argument collapses, because it depended on an infinite number of shells extending forever, each contributing equal brightness. But in reality, the number of shells is finite, limited by how far light can travel in 13.8 billion years. There is a last shell, a final layer beyond which nothing contributes. And once you remove the infinite extension, the infinite brightness disappears, replaced by a finite amount of light, and that alone already dims the sky dramatically. But even this is not enough to explain the depth of the darkness you observe, because even with a finite universe, even with a limited number of stars contributing light, you might still expect a faint glow, a soft cosmic haze filling every direction, not the overwhelming blackness that dominates the sky. And that is because something else is happening. Something that does not just limit how much light reaches us, but actively reduces the energy of that light as it travels. Something that weakens it, stretches it, and slowly transforms it into something our eyes can no longer perceive. And to understand that, you have to let go of another intuitive idea, on the idea that space is static, unmoving, unchanged, because the truth is far stranger than that. Space itself is expanding, and that expansion does not just move galaxies apart, it changes the very nature of the light traveling through it. And once you see how, the darkness of the universe becomes not just understandable, but inevitable, not an accident, not a mystery, but a direct consequence of the way reality is built. Even if the universe has a beginning, even if only a finite amount of light has had time to reach us, there is still another layer to the darkness, something more subtle, but far more devastating, because the light that does reach us is not the same light that was originally emitted. It has been changed along the way, altered by the expansion of the universe itself. Because space is not a fixed stage where events unfold. It is dynamic, stretching, growing, expanding in every direction, and this expansion has a direct effect on light. As a photon travels through space, the space it occupies stretches, and when that happens, the wavelength of the photon stretches with it, becoming longer, lower in energy, and less visible. This is known as redshift, and it is not a minor effect. It is cumulative and relentless. The farther light travels, the more space it crosses, and the more it is stretched. A photon that began as high-energy ultraviolet light can arrive as visible light or even infrared, or in extreme cases, as microwave radiation completely invisible to the human eye. And this means that much of the light produced by distant stars and galaxies never reaches us in a form we can see. It has been shifted out of the visible spectrum entirely, transformed into something colder, weaker, and harder to detect. And the deeper you look into space, the further back in time you are seeing, and the more extreme this redshift becomes. Galaxies billions of light years away are not just dim, they are fundamentally altered. Their light stretched so much that what was once bright and energetic becomes faint and invisible, and this effect compounds with distance, meaning that even if distant shells of stars exist within the observable universe, their contribution to visible brightness is dramatically reduced, not just by distance, but by the expansion of space itself. And this leads to one of the most profound realizations about the cosmos. The universe is not simply failing to deliver enough light. It is actively draining the energy from that light as it travels, weakening it over billions of years. And nowhere is this more evident than in the cosmic microwave background, the oldest light in the universe. When it was first emitted, roughly 380,000 years after the Big Bang, it was a blazing field of visible radiation, a uniform glow filling every direction. The sky at that time would have been bright, completely filled with light, but over billions of years of expansion, that light has been stretched by a factor of over 1,000, turning it into microwave radiation at a temperature of just 2.7 degrees above absolute zero, completely invisible to human senses. The brightest light the universe ever produced has been transformed into a faint whisper of energy, still present, still everywhere, but undetectable without specialized instruments. And this is what expansion does. It takes brightness and stretches it into darkness. It does not remove light, it dilutes it, spreads it, weakens it until it no longer contributes to what we see. And as the universe continues to expand, this process continues, accelerating, even driven by dark energy, meaning that more and more light will be stretched beyond visibility over time, making the universe not just dark, but progressively darker. And when you combine this with the finite age of the cosmos, the picture becomes clearer. There is only a limited amount of light that can reach us, and even that light is being steadily degraded as it travels, losing energy, shifting out of visibility, becoming less and less capable of illuminating the vast distances of space. And yet, even this is still not the full story, because there is another force at work one that operates at every distance, one that punishes brightness with a brutal simplicity, a law so fundamental that it applies to every source of light in the universe without exception. And it is this law, combined with everything you have already seen, that ultimately ensures the dominance of darkness across the cosmos. There is a rule so simple that you learned it without realizing, a rule that governs every candle, every lamp, every star, and yet when applied to the scale of the universe, it becomes almost cruel in its consequences. This is the inverse square law, and it states that the brightness of a light source decreases with the square of the distance from it, not linearly, not gradually, but brutally. Because when you double the distance, the brightness does not become half, it becomes 1/4. When you increase the distance 10 times, the brightness becomes 1/100th. And when you increase it 1,000 times, it becomes 1/1,000,000th. The fall-off is not gentle, it is devastating. And at cosmic scales, it becomes the dominant force that determines what you see and, more importantly, what you do not see. Because even the most powerful sources of light are reduced to almost nothing across the vast distances between stars and galaxies. Consider something familiar, our sun. From Earth, it dominates the sky. It lights the entire planet. It warms oceans, drives weather, fuels life itself. But move that same sun to the distance of the nearest star system, Alpha Centauri, just over 4 light years away, and its brightness collapses by a factor of tens of billions. What was once overwhelming becomes a faint point of light, barely visible against the darkness, and that is the nearest star. Most stars are far more distant, scattered across the Milky Way at separations of thousands or tens of thousands of light years, their light diminished to the point where individually they contribute almost nothing to the overall brightness of the sky. And when you step beyond our galaxy, the situation becomes even more extreme. The Andromeda Galaxy contains roughly 1 trillion stars, each one a nuclear furnace burning with immense power. Yet from Earth, it appears as a faint smudge, barely visible even under ideal conditions. 1 trillion stars reduced to a whisper. And that is because the inverse square law punishes distance relentlessly. No matter how much light a source produces, spreading that light across immense distances dilutes it to near nothing, and this effect applies universally. Every star, every galaxy, every cluster, no exceptions. And now you begin to see why the darkness persists, because even though there are vast numbers of stars, their individual contributions to the brightness of the sky are crushed by distance. And unlike the infinite universe assumption, where distant shells compensate with more stars, in a finite universe with redshift and expansion, that compensation fails. The outer shells contribute less and less, not equal amounts, their light weakened by both distance and the stretching of space. And so, instead of building toward brightness, the contributions fade, becoming smaller, weaker, less significant, until the cumulative effect is not a glowing sky, but a dark one. And this is why even enormous concentrations of stars fail to illuminate the universe, because the distances are too large, the dilution too severe, and the geometry too unforgiving. But even this still does not capture the full weight of the darkness, because there is something even more fundamental at play, something that goes beyond laws of light and distance, something that defines the very structure of the universe itself. And that is the overwhelming dominance of emptiness. The universe is not simply large, it is overwhelmingly, almost incomprehensibly empty. And this emptiness is not a detail, it is the defining feature of cosmic structure. Because when you think of space, you might imagine a field filled with stars, galaxies, glowing clouds. But in reality, those things are rare, isolated, separated by distances so vast that they become almost irrelevant to one another. The space between stars within our own galaxy is measured in light years, typically 4 to 5 light years between neighboring stars, which means trillions of miles of near-perfect vacuum separating each source of light. If you scaled the sun down to the size of a tennis ball, the nearest star would be another tennis ball, placed over 1,000 kilometers away, and everything in between would be empty, not dimly lit, not filled with glowing gas, but almost entirely nothing. And this is within a galaxy, one of the most densely populated structures in the universe. When you move beyond galaxies, the emptiness becomes even more extreme. Galaxies themselves are separated by millions of light years, clusters of galaxies by tens of millions. And between these structures lie vast regions known as cosmic voids, enormous bubbles of space, hundreds of millions of light years across, containing almost no galaxies at all. These voids make up the majority of the volume of the universe, meaning that most of the cosmos is not just dark, but structurally empty. And this emptiness has a profound consequence. It ensures that light has nothing to interact with, nothing to scatter off, nothing to accumulate into a background glow. Instead, it travels in straight lines, spreading out, thinning, becoming less dense as it moves through the void. And because the sources of light are so sparsely distributed, their radiation rarely overlaps in a meaningful way. Each star illuminates its immediate surroundings, but beyond a relatively short distance, its light becomes negligible, swallowed by the vastness of space. And when you combine this with everything you have already seen, the finite age of the universe limiting how much light can reach us, the expansion of space stretching that light into lower energy forms, the inverse square law crushing brightness with distance, and now the overwhelming geometry of emptiness ensuring that light sources are few and far between, the result becomes unavoidable. The universe is not failing to be bright. It is structured in such a way that brightness can never dominate. The fire exists, the stars burn with unimaginable energy, but they are scattered across a volume so vast that their combined output becomes insignificant, diluted into near nothingness. And this is why the night sky is dark, not because there is a lack of light, but because there is too much space, too much distance, too much emptiness for that light to ever fill. And once you begin to feel the scale of that emptiness, the darkness above you stops being surprising and instead begins to feel inevitable. At this point, it might feel like the darkness has been explained. Distance, expansion, finite time, all working together to weaken the light. But there is a deeper realization waiting beneath all of it. Something that changes not just how you see the night sky, but how you understand reality itself. Because the universe is not just dark, it is mostly nothing, not metaphorically, not philosophically, but physically, measurably, overwhelmingly empty. And this emptiness is not confined to the vast spaces between galaxies. It exists at every scale, including the one you are most familiar with, the scale of matter itself. Because everything you have ever touched, everything you have ever seen, is made almost entirely of empty space. An atom, the basic building block of matter, consists of a tiny nucleus surrounded by a cloud of electrons, and the distance between that nucleus and the electrons is enormous relative to their size. If you were to scale a hydrogen atom so that its nucleus was the size of a small marble, the electron would be orbiting hundreds of meters away, and everything in between would be empty. No particles, no structure, just vacuum. This means that the solid objects you interact with every day, your hands, the ground beneath you, the air around you, are not truly solid. They are mostly empty space, held together by forces. And this pattern does not stop at the atomic level. It repeats across the entire universe. May scale up from atoms to solar systems, and you find the same structure, vast emptiness, punctuated by small, dense objects. The planets orbit the Sun at distances that dwarf their own sizes. The Sun itself occupies a tiny fraction of the volume of the solar system, and beyond the outermost planets lies an enormous region of space containing almost nothing. And when you scale up further to galaxies, the pattern intensifies. Stars are separated by light years of empty space, galaxies by millions of light years, clusters by tens or hundreds of millions, and between them lie cosmic voids that dominate the volume of the universe. At every level, the same truth emerges. Matter is rare. Emptiness is the rule. And this has a direct consequence for light, because light requires matter to be produced, stars to generate it, gas to scatter it, objects to reflect it. And when matter is sparse, light is sparse, not because it is weak, but because it has nowhere to originate from and nowhere to accumulate. And so the universe is not a bright place with occasional dark gaps. It is a dark place with occasional bright interruptions. The stars are not the background, they are the exception. Brief, localized events where enough matter has come together to ignite nuclear fusion, and everything else is void. And once you begin to see this, the darkness stops feeling like something that needs to be explained, and starts to feel like something that was inevitable from the very beginning, because the universe is built from emptiness, structured by separation, and defined by the absence of matter across most of its volume. There was a moment in the history of the universe when the sky was not dark, a brief, extraordinary period when the expectation of a bright sky was actually correct, when every direction you looked would have been filled with light, not from stars, because stars did not yet exist, but from something even more fundamental. The afterglow of the Big Bang itself, roughly 380,000 years after the universe began, conditions had cooled enough for atoms to form, allowing light to travel freely for the first time. And at that moment, the entire universe was filled with radiation at a temperature of about 3000 Kelvin, a glowing, luminous field of energy that permeated every direction. If you could have existed at that time, the sky would not have contained stars. It would have been a uniform, blinding brightness, like being surrounded by the surface of a star in every direction. There would have been no darkness, no gaps, no blackness at all. This was the one and only time the universe truly illuminated itself completely. And for a brief window, the logic of infinite brightness seemed to hold. Every line of sight ended in light. Every region of space contributed equally. The sky was filled, continuous, radiant. But this state did not last because the universe was expanding. And as it expanded, that light began to stretch, its wavelength increasing, its energy decreasing. What was once visible, light slowly shifted into infrared, then into microwave radiation, and over billions of years, that once brilliant glow was diluted into something almost undetectable. Today, we still observe this radiation as the cosmic microwave background in a faint signal with a temperature of just 2.7 Kelvin, barely above absolute zero. It is everywhere, filling all of space, but it is invisible to human eyes, detectable only with sensitive instruments. The brightest moment in the history of the universe has been transformed into one of its faintest features. And this transformation is permanent, irreversible. The universe cannot return to that state of uniform brightness because the expansion that stretched the light continues to operate. And as it does, it pushes everything further apart, reduces the density of matter, and prevents light from ever filling space in the same way again. Stars eventually formed, igniting new sources of light across the cosmos. But they could never recreate that original brightness because they are too sparse, too localized, too separated by the vast emptiness of space. And so the universe transitioned from a state of complete illumination to one of overwhelming darkness, and it will never go back. The era of uniform brightness was brief, lasting only a fraction of a percent of the universe's total lifetime, while the darkness that followed has persisted for billions of years and will continue for trillions more. And this reveals something deeply unsettling. The universe once had enough light to fill itself completely, and it lost it, not through destruction, not through failure, but through the natural consequences of its own expansion. The brightness was stretched away, diluted, transformed into something too weak to see, and what replaced it was not another form of light, but darkness, vast, dominant, and enduring, in the default state to which the universe has returned and will remain in for the rest of its existence. The darkness you see tonight is not a fixed condition. It is not stable. It is not even at its final state. It is part of a process, a long, slow, irreversible drift towards something even deeper, because the universe is not only dark, it is becoming darker with time. And this is not speculation. It is something we can measure, something we can observe across billions of years of cosmic history. When astronomers look far into space, they are also looking back in time. And what they see is a universe that was once far more active, far more luminous, filled with galaxies forming stars at rates far higher than what we observe today. There was a period often called cosmic noon, around 10 to 11 billion years ago, when the universe was producing stars at its peak. Galaxies were dense with gas, collapsing, igniting, generating enormous amounts of light, far more than the present-day universe produces. But that era has passed. The rate of star formation has been declining ever since, steadily, relentlessly, over billions of years. And today, the universe forms new stars at only a small fraction of its peak rate, roughly a few percent. The fire is fading, not suddenly, not catastrophically, but gradually, like embers cooling after a long burn. And the reason is simple. Stars consume fuel. They convert hydrogen into helium, releasing energy in the process. And over time, the supply of coal gas needed to form new stars becomes depleted, heated, or dispersed. Galaxies lose their ability to sustain high rates of star formation, and without new stars replacing the old ones, the total luminosity of the universe begins to decline, slowly at first, but inevitably, and this trend will continue. Most of the stars that will ever exist have already formed. The universe has already done the majority of its work, and what remains is a long, slow winding down, where fewer stars ignite, more stars age, and the overall brightness decreases. And this means that the darkness is not just dominant, it is winning, gaining ground, expanding its reach as the sources of light become less frequent and less powerful. And this process is amplified by the expansion of the universe itself, which continues to stretch space, increasing the distances between galaxies, isolating them from one another, reducing the exchange of matter, further suppressing star formation. And over unimaginable spans of time, this leads to a future where galaxies drift so far apart that they effectively disappear from each other's skies, leaving only local stars visible, surrounded by an even deeper, more complete darkness, a darkness not just between stars, but beyond them, a darkness that reflects not just the structure of space, but the evolution of time itself, because the universe is not maintaining a balance between light and dark. It is moving steadily, irreversibly toward darkness. There will come a time when the stars you see tonight no longer exist, not replaced, not renewed, but gone. And this is not a dramatic collapse, not an explosion, but a quiet fading, stretched across timescales so vast that they are almost impossible to grasp. Stars have lifetimes. They are not eternal. They burn fuel. And when that fuel runs out, they change, they collapse, they cool, they die. Massive stars burn quickly and end in violent supernova explosions, while smaller stars, like our Sun, burn more slowly, eventually shedding their outer layers and leaving behind dense remnants. And the smallest stars of all, red dwarfs, burn so slowly that they can last for trillions of years, far longer than the current age of the universe. But even they are not immortal. Given enough time, every star will exhaust its fuel, and when the last stars finally fade, the universe will enter a new era, one where no new light is produced, where the only remaining sources of illumination are the remnants of once bright stars, white dwarfs slowly cooling, neutron stars emitting faint radiation, black holes radiating energy through quantum effects. But even these will not last forever. White dwarfs will cool into black dwarfs, neutron stars will lose their energy, and black holes, over unimaginable timescales, will evaporate through Hawking radiation, leaving behind nothing but low-energy particles, drifting through an ever-expanding void. And this leads to what is known as the Dark Era, a period in the far future of the universe where there are no stars, no galaxies in the familiar sense, no sources of significant light at all, just a cold, sparse, nearly empty cosmos, expanding forever, growing colder, darker, and more dilute. This is not a temporary phase. It is the final state, the long-term destiny of the universe as we understand it. And when you compare this future to the present, something unsettling becomes clear. We are living in a brief window of time when the universe is still lit, when stars still burn, when galaxies still shine. But this window is small compared to what comes before and after. The universe was dark before the first stars formed, and it will be dark again long after the last ones fade. The era of light is not the norm, it is the exception, a temporary condition in an otherwise dark cosmos. And this means that the night sky you see, with its scattered stars against a black background, is not just a snapshot of the present. It is a glimpse into both the past and the future, a reflection of a universe that emerged from darkness, briefly ignited, and is now slowly returning to the state it began in. And once you begin to feel the scale of that timeline, the darkness above you starts to carry a different meaning. Not just absence, not just emptiness, but inevitability. The quiet, steady conclusion of everything that produces light. There is a quiet but devastating realization hiding beneath everything you've heard so far. And once it settles in, it changes the way you interpret the entire universe, because the darkness is not something light is gradually overcoming. It is something light was never capable of overcoming in the first place, not even at its peak, not even when star formation was at its highest, not even when galaxies were crowded and active and filled with burning fuel. Because no matter how many stars exist, no matter how much energy they release, the structure of the universe ensures that their combined light will always fall short, always remain localized, always fail to fill the vastness between them. And this is not due to a lack of power. Stars are extraordinarily powerful, each one converting mass into energy at rates that dwarf anything humanity has ever produced. Across the observable universe, the total luminosity is staggering, almost beyond comprehension. And yet all of that energy is spread across a volume so immense that its density becomes negligible. The light does not accumulate, it disperses, it stretches, it fades, and the distances are simply too large for it to maintain any meaningful presence outside its immediate surroundings. This means that even if you could increase the number of stars, even if you could imagine a universe with 10 times or 100 times more stellar activity, the outcome would not fundamentally change. The darkness would still dominate, because the problem is not the amount of light, it is the scale of the space it must fill. And that scale grows faster than any increase in luminosity could compensate for. Space expands, distances increase, volumes grow, and light, no matter how intense at its source, becomes diluted to insignificance across those scales. And so the darkness is not a temporary imbalance, not a phase waiting to be corrected. It is the inevitable result of how the universe is structured. The geometry ensures it, the physics enforces it, and the outcome is already written into the fabric of reality itself. Light never had a chance to win. It was always going to be outmatched by distance, by expansion, by the overwhelming emptiness that defines the cosmos. Every star you see in the sky is an island, not metaphorically, but physically, on isolated pockets of energy surrounded by an ocean of vacuum so vast that their influence barely extends beyond their immediate vicinity. And this isolation is not just a feature of distant galaxies or deep space. It applies even within our own cosmic neighborhood. Consider the sun. It feels dominant, powerful, central to everything in our experience. And within the solar system, it is, Its light fills the space around it, illuminates planets, creates day and night, defines the rhythm of life on Earth. But beyond a certain distance, its influence collapses rapidly. Move just a few light years away, and the Sun becomes indistinguishable from the countless other stars, a faint point of light with no ability to illuminate its surroundings in any meaningful way. And this is true for every star. Each one creates a small sphere of influence, a region where its light is strong enough to be noticeable. But beyond that region, the brightness drops off so quickly that it effectively disappears into the background of space. And these spheres do not overlap in any significant way. They are separated by vast distances, leaving enormous regions of space completely unlit. And when you scale this up to galaxies, the same pattern holds. Galaxies are not continuous fields of light. They are collections of isolated stars, each with its own limited reach. And the combined glow of a galaxy is only visible from a distance because of the sheer number of stars. But even then, it appears as a faint, diffuse object against the darkness, not a source of widespread illumination. And between galaxies, the separation becomes even more extreme. Millions of light years of empty space with no significant light sources at all. And this creates a universe that is not interconnected by light, but fragmented into isolated regions, each one glowing faintly, surrounded by darkness that extends far beyond its boundaries. And this fragmentation is what prevents the universe from ever appearing bright on a large scale, because the light is trapped in these islands, unable to bridge the immense distances between them, unable to accumulate into a continuous field. And so what you see when you look at the night sky is not a uniform distribution of light, but a sparse scattering of isolated sources, each one separated by distances so vast that their combined effect is negligible. And this is why the darkness persists, not because light is weak, but because it is confined, localized, unable to escape the overwhelming separation that defines the structure of the cosmos. If you could step outside the limits of your perspective and see the universe from far beyond your galaxy, what you would not find is a smooth field of stars scattered evenly through space. Instead, you would see structure, a vast, intricate network stretching across unimaginable distances, something known as the cosmic web, where galaxies are not randomly placed, but arranged along enormous filaments and walls, thin strands of matter that intersect at dense nodes called galaxy clusters. And between these filaments lie the voids, immense regions of space containing almost nothing at all. And this structure is not a minor detail. It defines how matter and light are distributed across the entire universe, because most of the galaxies, most of the stars, in most of the light-producing matter is confined to these filaments, while the voids occupy the majority of the volume, meaning that most of space is not just empty, but structurally empty, shaped by gravity into regions where matter has been drawn away, leaving behind vast expanses of darkness. And this arrangement has profound consequences for light, because it means that illumination is concentrated in narrow regions, while the overwhelming majority of space receives almost no light at all. And even within the filaments, the density of matter is still incredibly low compared to anything we experience on Earth. So the light that is produced remains localized, unable to spread across the immense distances separating one filament from another. And when you visualize this, the universe begins to look less like a glowing sphere and more like a delicate web of faint threads suspended in a sea of blackness. The light is there, but it is confined, stretched thin, overwhelmed by the sheer scale of the voids that surround it. And those voids are not small. They can span hundreds of millions of light years, regions so vast that a photon could travel for millions of years without encountering a single galaxy. And this is the true architecture of the cosmos, not a place filled with light, but a place where light is trapped in narrow structures, separated by enormous regions of darkness. And once you begin to see the universe this way, the night sky starts to make sense, because what you are seeing is not a uniform field of stars, but a tiny cross-section of this vast web, and a glimpse of a structure where darkness is not the exception, but the dominant feature. There is a boundary to what you can see, not because your eyes are limited, not because your telescopes are insufficient, but because the universe itself imposes a limit, and that limit is absolute. It cannot be overcome. It cannot be bypassed. It is built into the very nature of reality. This boundary is known as the observable horizon, and it represents the maximum distance from which light has had time to reach you since the beginning of the universe. Beyond this horizon, there may be more galaxies, more stars, more structure, but none of it is visible. None of it contributes to what you see, because the light has not arrived and may never arrive due to the expansion of space. And this means that the darkness you observe is not just a result of what is present, but also of what is absent from your view. Entire regions of the universe that exist but are forever beyond your ability to detect. And this horizon is not static. It evolves over time. As the universe expands, some regions move beyond the point where their light can ever reach us, effectively disappearing from the observable universe, and this creates a situation where the visible portion of the cosmos is not only finite, but also shrinking in terms of what can influence us in the future. Galaxies that are currently visible will eventually fade from view, their light stretched beyond detection, their presence erased from our observable reality. And this has a profound implication. The universe is not just dark because of what it contains, but because of what it hides, vast amounts of structure and light that are permanently inaccessible, forever beyond the reach of observation. And this reinforces the dominance of darkness, because even if there is more light beyond the horizon, it does not matter. It does not contribute. It does not change what we see. The darkness remains, shaped not only by the distribution of matter and the behavior of light, but also by the fundamental limits of observation itself. And this means that the night sky is not just a window into the universe. It is a filtered view, a restricted slice of a much larger reality, one where the majority of what exists is either too far, too faint, or too distant in time to ever be seen, leaving behind a sky that appears overwhelmingly dark, not because light is absent, but because the universe only allows a small fraction of it to reach us at all. There is a limit woven into the fabric of the universe, a boundary that nothing can cross, no matter how powerful, no matter how energetic, and that limit is the speed of light, approximately 300,000 kilometers per second. It feels unimaginably fast in any human context. A beam of light can circle the Earth more than 7 times in a single second. It can travel from the moon to Earth in just over a second, from the sun to Earth in about 8 minutes. And yet, when you place that speed against the scale of the universe, it becomes something else entirely. It becomes a restriction, a bottleneck, a constraint that shapes everything you can ever observe. Because light does not arrive instantly. It travels. It takes time. And that time accumulates over vast distances, turning the universe into something more like a delayed image than a present reality. Every star you see is not as it is now, but as it was when its light began its journey years, thousands of years, millions or even billions of years ago. And this delay means that the universe you observe is always incomplete, always missing information that has not yet had time to reach you. And this incompleteness is not something technology can fix. It is not a limitation of your instruments. It is a fundamental feature of reality. No telescope, no matter how powerful, can collect light that has not yet arrived. And so the speed of light creates a hard boundary, a horizon beyond which information is simply unavailable. And this has a direct consequence for the brightness of the sky, because it means that light from distant regions cannot contribute until it has completed its journey. And in a universe with a finite age, there are always regions whose light is still traveling, still crossing the void, still on its way. And until it arrives, those regions remain dark to you, invisible, absent from your sky. And this is not just a small effect at the edges. It defines the entire observable universe, a sphere of visibility determined by how far light has been able to travel since the beginning. And beyond that sphere lies more universe, perhaps infinitely more. But none of it matters to what you see, because its light has not reached you and may never reach you. And so the speed of light is not just a speed. It is a filter determining what exists in your observable reality and what remains forever hidden. And this filter ensures that no matter how much light exists in the universe, only a limited portion of it can ever contribute to the brightness of your sky, reinforcing the darkness, not by removing light, but by delaying it, by holding it back across distances so vast that even billions of years are not enough to bridge them. You might imagine that as time passes, as the universe ages, more and more light would eventually arrive, that the darkness would slowly fill in, that distant regions would gradually become visible. And while this is partially true, it is not the full story, because the universe is expanding, and that expansion changes the rules in a profound way. It means that some regions of space are moving away from us so quickly that their light will never reach us at all, no matter how long we wait. And this creates a second kind of horizon, not just a boundary of what we can see now, but a boundary of what we can ever see, a limit beyond which events are permanently disconnected from our observable future. And this is known as the cosmic event horizon, and it represents one of the most unsettling aspects of the universe, because it means that there are galaxies whose light is currently on its way to us, but will never arrive, because the space between us and them is expanding faster than the light can cross it. The photons are traveling toward us at the maximum speed allowed by physics, and still they are being carried away, stretched by the expansion of space itself, never closing the distance. never reaching their destination. And this means that parts of the universe are not just unseen, they are unseeable, forever beyond the reach of observation. And as time goes on, more and more regions cross this horizon, disappearing from our observable universe, their light redshifted into invisibility, their signals lost. And this process ensures that the universe will not become brighter over time. It will become darker because the pool of accessible light is not increasing indefinitely. It is limited and in some cases shrinking. And this reinforces a deeper truth. The darkness you see is not temporary. It is not something that will be resolved as more light arrives. It is a permanent feature of a universe where expansion and the speed of light work together to isolate regions of space from one another, creating boundaries that cannot be crossed, and ensuring that no matter how much light exists beyond those boundaries, it will never contribute to what you see. And so the horizon is not just a limit of observation. It is a defining feature of the cosmos, shaping the very nature of what is visible and what remains forever hidden in the darkness. There is a quiet process happening everywhere in the universe, constant, unavoidable, and almost invisible unless you step back far enough to see it. And that process is dilution, not just of light, but of everything. Because as the universe expands, it does not simply move objects apart. It stretches the space between them, increasing the volume that everything must occupy. And when volume increases, density decreases. This is true for matter, for radiation, for energy itself. Everything becomes more spread out, more diffuse, more diluted over time. And this has a direct and profound effect on brightness. Because brightness is not just about how much light exists, but how concentrated that light is within a given region. A candle in a small room can illuminate everything, but the same candle in a vast open field becomes almost irrelevant. And the universe is not just a large space. It is a space that is continuously becoming larger, which means that the light within it is continuously becoming less concentrated, less able to accumulate into anything that resembles a uniform glow. And this dilution compounds with distance because as photons travel through expanding space, they are not only redshifted, losing energy, they are also spread across an ever-growing volume, reducing their density even further. And so even if the total amount of light remains the same, its ability to illuminate space diminishes, not because it disappears, but because it becomes too thinly distributed to have any meaningful effect. And this is why the universe feels so empty, so dark, even though it contains vast amounts of energy, because that energy is not concentrated. It is diluted across a volume that is almost incomprehensibly large. And as time goes on, this dilution increases. The universe grows, the distances expand, the density drops, and the light becomes less and less significant relative to the space it occupies. And this process does not reverse. It does not stabilize. It continues indefinitely, ensuring that the darkness is not just maintained, but deepened, not through the loss of light, but through the relentless expansion of the space that light must fill. Everything you intuitively believe about light comes from a world that is small, contained, and densely populated with sources of illumination. A world where distances are measured in meters or kilometers, where light sources are relatively close together, and where the inverse square law operates over ranges that are manageable, understandable, predictable. In that world, adding more light sources makes things brighter, increasing intensity fills space, and darkness retreats as illumination increases. This intuition is deeply ingrained. It shapes how you think about brightness, about visibility, about the relationship between light and space. But the universe does not operate on those scales. It operates on distances so vast that your intuition breaks down completely, because the assumptions that hold true in a room or even across a city simply do not scale to light years and beyond. In the universe, adding more light sources does not guarantee brightness, because those sources are separated by distances so large that their contributions do not overlap in any meaningful way. The light from one star does not significantly illuminate the region around another. The combined effect does not build into a continuous glow. Instead, it remains fragmented, localized, isolated, and this is where intuition fails most dramatically, because your brain expects light to fill space, to accumulate, to create a background level of illumination. But in the universe, space is too vast, too empty, too expansive for that to happen. The photons disperse, the distances dominate, and the result is not a gradual fading of brightness, but an abrupt transition from light to darkness, where illuminated regions end sharply and are immediately replaced by vast expanses of blackness. And this is why the night sky feels the way it does. Not softly glowing, not gently illuminated, but starkly contrasted with bright points of light against a background that appears completely empty. And once you recognize this failure of intuition, you begin to see the universe differently, not as a place where light is abundant but uneven, but as a place where light is fundamentally constrained, unable to overcome the scale of the space it inhabits. And this realization is what makes the darkness feel so absolute, so dominant, because it is not just the absence of light, it is the consequence of a reality that operates far beyond the limits of human intuition. Every night, without exception, the universe shows you exactly what it is, and it does so in the simplest possible way. It gives you darkness, not hidden, not subtle, not buried in equations or distant observations, but visible to your naked eyes, stretching across the sky in every direction. And for most of your life, you have treated that darkness as a background, something passive, something unimportant. But it is not passive. It is the most honest statement the universe can make about itself, because everything you have learned so far, the finite age, the expansion of space, the redshift of light, the inverse square law, the overwhelming emptiness, all of it leads to the same conclusion. The darkness is not a flaw. It is not a temporary gap waiting to be filled. It is the expected outcome, the natural state of a cosmos built from distance, time, and separation. And once you understand that, the night sky stops being a simple collection of stars and becomes something else entirely. It becomes evidence that the universe is not infinite in the way you might imagine, not eternal in the way you might assume, not filled with light in the way your intuition expects. It becomes a direct observation of limits on how far light can travel, limits on how much energy can accumulate, limits on what can ever be seen from any single point in space. And this is what makes the darkness so powerful, because it is not something you need advanced instruments to detect. It is something you experience constantly, something that has always been there, quietly contradicting the assumptions that feel most natural to you. And this contradiction is what drove centuries of scientific thought, because it forces a question that cannot be ignored. Why is the sky dark? And the answer, as you are beginning to feel, is not a single idea, but a convergence of many, each one removing a piece of brightness, each one reinforcing the dominance of darkness, until what remains is the sky. Vast, quiet, and overwhelmingly black. And this means that every time you look up, you are not just seeing stars. You are seeing the boundaries of reality itself, written in contrast. Light against darkness, presence against absence, and the absence is what tells you the most. At first glance, the universe appears full, filled with stars, galaxies, glowing structures scattered across the sky. But this impression is misleading because it is based on what stands out, what emits light, what draws your attention. And what draws your attention is only a tiny fraction of what actually exists. The vast majority of the universe does not shine. It does not emit visible light. It does not reveal itself easily. And this creates a bias in perception, a tendency to overestimate the importance of the bright regions and underestimate the significance of the dark ones. But in reality, the dark regions are not empty in a trivial sense. They are empty in a structural sense. They define the space in which everything else exists. They determine the distances, the separations, the geometry of the cosmos. And this means that the universe is not a place filled with light that happens to contain some darkness. It is a place filled with darkness that happens to contain some light. And this reversal is crucial because it changes how you interpret everything you see. The stars are not the default. They are the exception. Brief concentrations of matter and energy that stand out against a much larger backdrop of emptiness. And this emptiness is not static. It is expanding, growing, increasing its dominance over time as galaxies move apart, as star formation declines, as light is stretched and diluted. And this leads to a universe that becomes progressively less luminous, not because it is losing energy, but because that energy is being spread across an ever-increasing volume, making it less and less noticeable. And this process is already well underway. The brightest era of the universe has passed. The peak of star formation is behind us. And what remains is a slow transition toward a state where light becomes rarer, weaker, more isolated, and eventually disappears altogether, leaving behind a cosmos that is almost entirely dark. And when you place yourself within this context, when you realize that you are living in a brief moment of relative brightness within an otherwise dark universe, the night sky begins to feel different, not just as a view, but as a statement, a reminder that what you are seeing is temporary, that the light you depend on, the stars you observe, are part of a fleeting phase in a much larger, much darker story. And that story is still unfolding, slowly, quietly, in every direction you look. There is a number hidden beneath everything you have been hearing, a number so small that it quietly undermines every intuitive belief you have about how much light the universe actually contains in a meaningful way. Because while it is true that there are unimaginable numbers of stars, while it is true that the total energy output of the cosmos is staggering, the fraction of that energy that actually contributes to what you can see is almost negligible, not because the rest does not exist, but because it is either too far, too stretched, too diluted, or too isolated to matter. And when scientists attempt to measure the total amount of visible light arriving from all galaxies across the entire observable universe, they arrive at a value so small that it almost feels like an error, a faint background glow that is effectively indistinguishable from nothing without extremely sensitive instruments. This is known as the cosmic optical background, and it represents the accumulated light from billions of years of star formation across trillions of galaxies. And yet, when expressed in physical terms, it amounts to only a tiny trickle of energy per unit area, far below anything your senses could ever detect. And this reveals something deeply counterintuitive. The universe is producing enormous amounts of light, but almost none of it reaches you in a way that matters, because the vast majority of photons either never arrive or arrive so weakened that they fall outside the range of human perception. And this means that when you look at the night sky, you are not seeing a reduced version of a bright universe. You are seeing the only version that is physically accessible to you. The rest of the light exists, but it is effectively lost to distance, lost to expansion, lost to the geometry of space. And this makes the darkness even more profound, because it is not just the absence of visible light. It is the result of an overwhelming majority of light being rendered irrelevant by the conditions of the universe itself. And once you begin to grasp this, the stars you see start to feel different, not just as distant objects, but as rare survivors, the few sources of light whose photons have managed to cross the immense barriers of space and time to reach you, while the rest of the universe remains hidden, silent, and effectively invisible. Everything about the universe points in one direction, not toward accumulation, not toward brightness, but toward loss. Not a sudden or dramatic loss, but a slow, continuous, inevitable erosion of energy, structure, and visibility. Because every mechanism you have encountered so far contributes to this trend. The finite age of the universe limits how much light can ever arrive. The expansion of space stretches that light, reducing its energy. The inverse square law spreads it across vast distances, diluting its intensity, and the geometry of emptiness ensures that sources remain isolated, unable to reinforce one another. And together these mechanisms form a system that does not preserve brightness, but steadily reduces its impact. And this system operates everywhere, at every scale, affecting every photon that travels through space, every star that emits light, every galaxy that forms and evolves. And the result is a universe where energy is constantly being redistributed in ways that make it less accessible, less concentrated, less capable of producing visible effect. And this is not a flaw. It is a natural consequence of the laws of physics, a reflection of how entropy operates on cosmic scales and was spreading energy across larger and larger volumes, reducing gradients, smoothing out differences, and moving the universe toward a state of uniformity. But that uniformity is not bright, it is dark, because when energy is evenly distributed across an enormous volume, its density becomes so low that it cannot produce visible light. It becomes background radiation, thermal noise, something that exists but cannot be perceived. And this is the direction the universe is heading, not toward a brighter state, but toward one where all energy is so evenly spread that no structure, no star, no galaxy can stand out. And this is why a darkness feels so dominant, because it is not just a present condition, it is the trajectory, the long-term outcome of a system that gradually erodes the visibility of everything within it. And once you understand the universe as a system of loss, the darkness stops feeling surprising and starts to feel inevitable, the natural endpoint of processes that have been unfolding since the beginning of time. There is a point at which numbers stop helping you understand reality and begin to dissolve it instead. And the darkness of space lives exactly at that point, because everything you have heard so far depends on scale. Distances so vast, volumes so immense, time so long that the human brain cannot hold them in any stable way. You can say billions of light years, trillions of stars, sextillions of photons, but those words do not translate into experience. They do not create a feeling. And without that feeling, it is easy to underestimate what those numbers actually imply. Because the problem is not just that the universe is large, it is that it is large in a way that overwhelms any attempt to compare it to anything familiar. And when scale reaches that level, intuition fails completely and the consequences become difficult to accept. Because what those scales imply is that even immense amounts of energy become irrelevant. Even the combined output of entire galaxies becomes negligible when spread across the volume they inhabit. And this is what breaks meaning. Not because the energy disappears, but because its effect becomes indistinguishable from zero at the scales that matter. And this is why the darkness feels so absolute, because the scale of the universe ensures that no matter how much light exists, it cannot accumulate in a way that produces a visible background. It cannot overcome the distances. It cannot compete with the expansion. It cannot fill the void. And so the darkness is not just the result of physical processes. It is the result of scale itself, a scale so extreme that it renders even the most powerful phenomena ineffective at the level of perception. And once you begin to feel this, once you begin to grasp how scale reshapes everything, the night sky starts to look different, not just as a collection of distant points, but as a demonstration of what happens when reality operates far beyond the limits of human comprehension, where quantities lose their intuitive meaning and only their consequences remain. And the consequence, written clearly across the sky, is darkness. Right now, at this exact moment, you are living in one of the rarest phases the universe will ever experience. A narrow window in time where light still exists in a meaningful, visible way, where stars are still burning, where galaxies are still forming new sources of illumination, where the night sky still contains points of light scattered across the darkness. And this moment feels normal, because it is the only one you have ever known. But in the context of the universe's full timeline, it is anything but normal. It is an exception, a brief period of activity surrounded by vast stretches of darkness before and after. Because before the first stars formed, the universe was dark, not empty of energy, but lacking any localized sources of visible light. And after the last stars fade, it will return to that state. But even more extreme, more empty, more diffuse, more silent. And the duration of this bright phase, the era of stars, is finite, kick-bounded, temporary, lasting perhaps a few 100 trillion years at most, which sounds enormous, but when compared to what comes after, it becomes almost negligible, because the future of the universe extends far beyond that, into timescales where stars no longer exist, where galaxies have dispersed, where black holes have evaporated, leaving behind a thin, cold sea of particles drifting through an ever-expanding void. And in that future, the darkness is not punctuated by light. It is complete, uninterrupted, permanent. And when you place your current moment within that timeline, something profound emerges. The light you see is not a stable feature of reality. It is a transient phenomenon, a temporary condition that will eventually disappear. And this realization changes the way you interpret the night sky, because it is no longer just a static view. It is a snapshot of a fleeting era, a moment where the universe is still capable of producing visible light, still capable of illuminating small regions of space, still capable of creating the contrast between light and darkness that you perceive. And once that capability fades, the darkness will remain not as a background, but as the entirety of the observable reality. And this means that the sky you see is not just a view of space. It is a view of time, a glimpse into a phase of the universe that is already passing, slowly, quietly, inevitably. And as you begin to feel that, the darkness takes on a different meaning, not just as a physical condition, but as a reminder that everything you see is temporary, part of a brief chapter in a much longer story defined almost entirely by the absence of light. There is a pattern that repeats at every level of the universe, from the smallest scales you can imagine to the largest structures ever observed. And that pattern is separation, not connection, not continuity, but distance placed between everything that exists. Because if you look closely enough, nothing in the universe truly touches anything else in a meaningful, continuous way. Atoms are mostly empty space, with particles held apart by forces rather than fused into solid blocks. Planets are separated from their stars by tens or hundreds of millions of kilometers. Stars are separated from each other by light years, galaxies by millions of light years, and even those galaxies are arranged in a web that leaves enormous voids between them. And this pattern is not accidental, it is fundamental. It is how the universe organizes itself under the influence of gravity, expansion, and the distribution of matter. And what it creates is a cosmos where everything that produces light is isolated, confined to its own region, unable to merge with others into a continuous field, unable to collectively fill the space around it. And this separation has a direct consequence. It prevents light from accumulating, because accumulation requires proximity. It requires sources close enough together for their radiation to overlap, to reinforce, to create a shared illumination. But the universe denies that proximity on every scale, pushing objects apart, stretching distances, ensuring that each source remains largely alone. And this is why even enormous numbers of stars fail to produce a bright sky, because they are not arranged in a way that allows their light to combine effectively. They are scattered, isolated, separated by distances that prevent their influence from extending beyond their immediate surroundings. And this turns the universe into something like a collection of isolated sparks in an ocean of darkness, each one burning intensely within its own small domain, but unable to illuminate the vast regions between them. And once you see this, the darkness begins to feel less like an absence and more like a structure, something that is built into the very arrangement of the cosmos. Not something that happens when light is missing, but something that exists because of how everything is placed, spaced, and separated across the universe. Light is not just illumination, it is information. Every photon carries with it a record of where it came from, what produced it, how it has changed along the way. And when you observe light from a star or a galaxy, you are receiving a signal, a message that has traveled across space and time to reach you. But the universe is not filled with these signals in a continuous stream. It is filled with gaps, vast intervals where no meaningful signal arrives, where the density of photons is so low that they cannot form a coherent picture. And this creates something that is rarely discussed but deeply important: the silence between signals. Because most of space is not illuminated by a steady flow of light, it is only occasionally intersected by photons traveling from distant sources. And between those arrivals, there is nothing. No continuous background, no steady glow, just the absence of detectable radiation. And this absence is not due to a lack of sources, but due to the immense distances between them, which spread out the photons so thinly that their arrival becomes sporadic, isolated, insufficient to create any sense of illumination. And this is why the universe appears so dark, not because light does not exist, but because it is too sparse, too infrequent, too widely separated in space to form a continuous presence. And when you think about it this way, the darkness becomes something else entirely. It becomes a kind of silence, a lack of signal, a condition where the information carried by light is so diluted that it cannot be perceived without extreme sensitivity. And this silence is everywhere. It fills the spaces between stars, between galaxies, between clusters, dominating the volume of the universe. And this means that what you experience as darkness is not just the absence of light, but the absence of detectable information, a state where the signals that do exist are too weak, too distant, too rare to register. And this reinforces the idea that the universe is not a place of continuous illumination, but a place where light appears only in isolated bursts, separated by vast regions of silence. And that silence is what defines the overall experience of the cosmos. Not the occasional signals that break it, but the overwhelming emptiness that lies between them. There is a quiet tragedy unfolding across the universe, not dramatic, not explosive, but constant and absolute. And it is this: most of the light that is ever produced will never be seen. Not by you, not by any observer anywhere, because it simply never arrives. It is not blocked, not destroyed, not absorbed in some catastrophic event. It is just lost to distance, lost to expansion, lost to the relentless stretching of space that carries it farther and farther away from any possible destination. Because when a photon is emitted, it begins a journey, and that journey is not guaranteed to succeed. It may travel for millions, billions, even trillions of years. But if the space between its origin and any observer expands faster than it can cross, it will never reach its goal. It will drift endlessly, its wavelength stretching, its energy fading, until it becomes indistinguishable from the background. And this means that the universe is constantly producing light that is effectively wasted. Energy that exists but never contributes to illumination, never forms an image never becomes part of any observable reality. And this is not a rare occurrence. It is the dominant outcome, because as the universe expands, more and more regions become causally disconnected. More and more photons are trapped in trajectories that will never intersect with observers. And this creates a cosmos where the majority of light is not just unseen, but unseeable, forever beyond the reach of perception. And this deepens the darkness in a way that is difficult to grasp, because it is not just about what you can see. It is about what can never be seen, what is permanently excluded from any possible observation. And when you think about the total energy output of the universe, the immense power of countless stars burning across billions of years, and then realize that most of that energy will never be observed by anyone, it changes the way you think about light itself. It is no longer something that fills space, but something that dissipates into it, something that spreads out and fades, rarely intersecting with anything that can detect it. And this means that the darkness is not just the absence of light, it is the result of light failing to connect, failing to bridge the distances, failing to complete its journey. And that failure is built into the very structure of the universe. If you remove everything that is temporary, everything that is localized, everything that requires specific conditions to exist, what remains is not light, not matter, not structure, but emptiness. Because emptiness is the default state of the universe, the condition that exists when nothing else is present, and everything else, stars, galaxies, clusters, is a deviation from that default, a rare configuration where matter has gathered, where energy has been concentrated, where conditions allow for the production of light, but those configurations are fragile, temporary, dependent on processes that cannot sustain themselves indefinitely. And once those processes end, once the fuel is consumed, once the structures disperse, the universe returns to its default state, emptiness. And this is why the darkness feels so complete, because it is not something that needs to be created. It is something that exists naturally, automatically, without effort. And this contrasts sharply with light, which requires specific conditions, high densities, nuclear fusion, gravitational collapse, all of which are rare and localized. And this imbalance means that darkness will always dominate, not because it is stronger, but because it is easier. It is what remains when everything else fades. And this applies not just to the future of the universe, but to its present structure. Because even now, most of the cosmos is already in that default state. Vast regions of space where nothing significant is happening, where no stars are forming, where no light is being produced, where the conditions are too diffuse, too sparse, too empty to support any form of illumination. And these regions are not exceptions. They are the majority. And when you look at the night sky, you are seeing a tiny fraction of the universe. The rare places where light exists, set against the overwhelming backdrop of where it does not. And this is why the darkness feels so dominant, because it is not competing with light. It is surrounding it, enclosing it, defining the space in which it appears. And once you begin to see the void as the default state, the darkness stops feeling like a mystery and starts to feel like a baseline, the natural condition of a universe where everything that produces light is temporary, localized, and ultimately unable to overcome the vast, enduring emptiness that surrounds it. There is something deeply unsettling about the direction the universe is moving toward, not just because it is getting darker, but because it is gradually erasing its own past, because the same processes that create darkness, expansion, redshift, and the limits imposed by the speed of light do not just reduce brightness, they remove information. They strip away the evidence of what once existed, and over vast stretches of time. This leads to a future where the universe becomes not only dark, but unknowable, because the light that carries information about distant galaxies is stretched beyond detection. The signals that reveal cosmic expansion fade into silence, and entire regions of space disappear beyond the observable horizon, leaving behind no trace that they were ever there. And this has a profound implication, because it means that the darkness is not just hiding what exists now, it is actively concealing what once existed, turning the universe into something that appears simpler, smaller, and more isolated than it truly is. And if you imagine an observer living in that distant future, they would look out at a sky containing only a handful of nearby stars, perhaps a single merged galaxy, surrounded by complete darkness. And from that perspective, they would have no way of knowing that the universe was once filled with countless galaxies, that it expanded, that it had a beginning. All of that information would be gone, carried away by the very processes that define the cosmos. And this reveals something extraordinary. The darkness is not just a physical condition, it is a filter on knowledge. It determines what can be known, what can be observed, what can be inferred about the nature of reality. And as it deepens, it reduces the amount of information available, making the universe appear simpler than it actually is. And this means that the sky you see tonight is not just a view of space. It is a temporary window into a much richer history, one that will not always be accessible. And once that window closes, once the light fades and the signals are lost, the universe will still exist, but its story will be hidden, locked away behind the same darkness that now feels so familiar. And this transforms the darkness into something more than absence. It becomes a kind of boundary on understanding, a limit not just on sight, but on knowledge itself. No matter where you are in the universe, no matter what planet you stand on, what galaxy you inhabit, or what technology you possess, the experience of the cosmos will always share one fundamental feature. Darkness will dominate, because this is not a local condition. It is not specific to Earth or our region of space. It is universal, built into the structure of reality at every scale. And this means that every possible observer, every civilization that could ever exist, will look up at their sky and see the same basic pattern, points of light scattered across an overwhelming background of blackness. And this has a strange consequence, because it means that the darkness is one of the few truly universal experiences, something that connects all possible perspectives across the cosmos, regardless of location, regardless of time. And yet, despite its universality, it does not reveal itself easily. It feels normal, expected, unremarkable, and because of that, it is rarely questioned, rarely examined, rarely understood for what it truly represents, which is a direct reflection of the deepest properties of the universe. And this creates a kind of paradox. The most obvious feature of the cosmos is also one of the least understood, not because it is complex, but because it is so familiar that it is overlooked. And once you begin to see it clearly, once you begin to understand the mechanisms behind it, the night sky changes. It stops being a passive backdrop and becomes an active statement, a constant reminder of the limits of light, the scale of space, the flow of time, and the dominance of emptiness. And this perspective is unavoidable. because you cannot step outside the universe to see it differently. You cannot remove yourself from the conditions that shape your observations. You are always inside it, always subject to the same laws, the same constraints, the same boundaries. And this means that the darkness you see is not just a feature of your environment. It is a feature of reality itself, something that cannot be escaped, only understood. And once you reach that understanding, the sky above you becomes something else entirely. It's not just a view, but a message, one that is always present, always consistent, and always pointing to the same conclusion, that the universe is far more defined by what is not there than by what is. There will be no moment when the universe suddenly goes dark, no dramatic instant where the lights switch off and everything disappears. Instead, the end of light will happen the same way everything else in the cosmos happens, slowly, quietly, almost imperceptibly at first, stretched across timescales so vast that no single observer could ever witness the full transition. Stars will continue to age and die, one by one, over trillions of years. The brightest and most massive will vanish first, leaving behind smaller, dimmer stars that burn longer but produce less light. And eventually, even those will exhaust their fuel, if fading into cold remnants that no longer shine. And as this process unfolds, the overall brightness of the universe will not collapse. It will decline, gradually, steadily, with fewer and fewer sources contributing to the illumination of space. Galaxies that once glowed with billions of stars will become collections of dark objects, orbiting silently, emitting almost no visible light. And the intervals between significant events, supernova explosions, stellar collisions, will grow longer and longer, separated by vast stretches of time where nothing luminous occurs. And this creates a universe where light becomes increasingly rare, increasingly isolated, until it reaches a point where the appearance of a new flash of brightness is not expected, but extraordinary, a rare interruption in an otherwise dark cosmos. And eventually, even those interruptions cease, leaving behind a universe where no new light is produced at all, only the fading remnants of what once existed. And this transition does not feel like an ending. It feels like a fading, a slow disappearance of contrast, where the distinction between light and dark becomes less meaningful because the light itself is no longer present in any significant way. And what remains is a uniform darkness, not dramatic, not oppressive, but complete, a state where the absence of light is no longer contrasted by its presence, but stands alone as the defining condition of the universe. In that distant future, when the stars have faded and the galaxies have dispersed, the universe will still exist, but it will be fundamentally different, not just in its physical state, but in its relationship to observation itself. Because without light, there is no way to see, no way to detect, no way to gather information about what remains. And this raises a question that is rarely considered. What does the universe mean when there is nothing left to observe it? Because all of the structure, all of the complexity, all of the processes that define the cosmos today are revealed through light, through the signals that travel across space and carry information from one place to another. And when those signals disappear, the universe does not stop existing, but it becomes inaccessible, not just to human perception, but to any form of observation that depends on the exchange of energy. And this leads to a state where the universe is effectively silent, not just visually, but informationally. A place where events may still occur, particles may still interact, but none of it can be detected, none of it can be known. And this is perhaps the most extreme consequence of the darkness. Not just that it dominates the cosmos, but that it eventually removes the possibility of witnessing the cosmos at all, turning the universe into something that exists without being observed, without being experienced, without being recorded. And this is not a sudden transformation. It is the culmination of all the processes you have seen, the gradual reduction of light, the expansion of space, the dilution of energy, all leading to a state where the conditions required for observation no longer exist. And when you compare that future to the present moment, the difference is striking, because right now, you are surrounded by light, able to see, to observe, to understand. But that ability is temporary, tied to the presence of stars, tied to the existence of luminous sources that will not last forever. And once they are gone, the universe remains, but its story becomes inaccessible, locked away behind a darkness that reveals nothing and hides everything. And this transforms the night sky into something more than a view. It becomes a reminder that observation itself is a fleeting condition, dependent on light that will not always be there. And that what you are experiencing now, the ability to look up and see the universe, is not guaranteed, but part of a brief and extraordinary phase in a much larger, much darker existence. There is a final shift in perspective that changes everything. And it begins when you stop thinking of darkness as nothing. Because the darkness of space is not an empty absence waiting to be filled. It is a presence, a condition with structure, with rules, with consequences. And what you call darkness is not simply the lack of light. It is what remains when all the processes that produce light are stripped away, when energy is diluted, when matter is dispersed, when distances become too large for interaction. And once you begin to see it this way, the darkness becomes something active, not in the sense that it does anything, but in the sense that it defines everything. It sets the stage. It determines the boundaries. It controls what can and cannot happen, because every source of light exists within it. Every photon travels through it. Every structure is embedded in it, and its properties, its vastness, its emptiness, its expansion, shape the behavior of everything else. And this means that the darkness is not secondary, it is primary. It is the environment in which all other phenomena occur. And this reverses the way you might normally think about the universe. Instead of seeing light as the default and darkness as the interruption, you begin to see darkness as the baseline and light as the deviation, rare, temporary, localized, and ultimately unable to change the overall condition. And this realization deepens the meaning of the night sky, because what you are looking at is not a field of stars with gaps between them, but a field of darkness with occasional points of light embedded within it. And those points, while visually striking, do not alter the underlying reality. They do not fill the space. They do not overcome the emptiness. They exist within it, briefly, before fading away. And when you extend this idea across the entire history of the universe, the conclusion becomes unavoidable. The darkness is not a phase, it is the default state, the condition that existed before the first stars formed, and the one that will exist long after the last ones fade. And this makes the presence of light feel almost fragile, a temporary arrangement of matter and energy that can exist only under specific conditions, surrounded on all sides by a vast and enduring emptiness that defines the true nature of the cosmos. Everything you have seen, every mechanism, every principle, every observation leads to a single, unavoidable conclusion. The balance between light and darkness in the universe is not close. It is not competitive. It is overwhelmingly, decisively tilted toward darkness. And this is not because light is weak, but because the conditions required for light to dominate are never met, not at any scale, not at any time beyond the earliest moments of the universe. Because for light to fill space, sources would need to be close enough, dense enough, and numerous enough to overlap in their influence to create a continuous field of illumination. But the universe does the opposite. It spreads matter out, it expands, it increases distances, it isolates structures, ensuring that no such overlap can occur. And even when the universe was at its brightest during the peak of star formation, the conditions were never sufficient to overcome this imbalance. The light was always confined, always diluted, always outmatched by the scale of the space it occupied. And as time goes on, this imbalance only grows stronger, because the processes that reduce brightness continue, while the processes that could increase it become less effective. Star formation declines, galaxies separate, light is redshifted and weakened, and the result is a universe that moves further and further away from any possibility of widespread illumination, toward a state where darkness is not just dominant, but absolute. And this imbalance is not something that will correct itself. It is the natural trajectory of the cosmos, the direction in which all physical processes point. And once you accept that, the night sky takes on a different meaning. It is no longer a temporary snapshot of a universe that might one day become brighter. It is a glimpse of reality that is already defined by darkness, a reality where light exists only in isolated pockets, unable to change the overall condition. And this makes the darkness feel not just inevitable, but fundamental, something that is built into the structure of the universe from the very beginning, and that will persist long after everything that produces light has disappeared. There comes a quiet moment, not dramatic, not sudden, but unmistakable, when everything you have been hearing stops feeling like information and starts feeling like reality, when the ideas settle into place and the night sky above you changes in a way that cannot be reversed, because you begin to see it differently, not as a familiar backdrop, not as something simple or passive, but as a statement, a direct expression of how the universe actually works. And in that moment, the darkness is no longer something you ignore. It becomes the dominant feature, the thing that defines everything else, the thing that was always there but never fully noticed. And what you see is not just blackness, but scale, distance, separation, time, all of it compressed into a single visual experience, because every patch of darkness represents regions where light has not arrived, cannot arrive, or has been stretched beyond recognition. And every star represents a rare exception, a point where conditions aligned just enough for light to exist in a visible form. And once you see that contrast clearly, the imbalance becomes undeniable. The darkness is not something surrounding the light. It is something the light is struggling within, something it cannot overcome. And this realization does not come with noise or intensity. It comes quietly, almost gently, the way understanding often does. But once it arrives, it changes everything, because you can no longer look at the sky without seeing the deeper structure behind it, without recognizing that what appears simple is actually the result of multiple layers of physical laws interacting across vast scales. And this changes the way you think about your place in the universe, because you are no longer standing under a sky filled with stars. You are standing inside a universe defined by emptiness, where the light you see is temporary, localized, and fragile, and where the darkness is the true baseline, the condition that exists everywhere else. And this shift in perception is what makes the entire journey meaningful, because it takes something ordinary, something you have experienced your entire life, and reveals it as something profound, something that carries information about the deepest nature of reality. And once you reach that point, the question is no longer why the universe is dark, but how it could ever appear otherwise. And after all of that, after the logic, the physics, the scale, the time, there is a final step, not one of understanding, but of acceptance. Because knowing why the universe is dark is one thing, but feeling what that means is something else entirely. And that feeling does not arrive as fear or urgency. It arrives as stillness, a quiet recognition of what is, because the darkness is not hostile. It is not something to resist or escape. It is simply the natural state of a universe that operates according to rules far larger than anything human experience is built to handle. And when you allow that idea to settle, the darkness begins to feel different, not as an absence, but as a presence, not as something lacking, but as something complete in its own way, because it does not need to be filled. It does not need to be changed. It simply exists. And everything else, light, stars, galaxies, are temporary variations within it. And this perspective brings a kind of calm, a sense that the universe is not broken or incomplete, but exactly what it must be, shaped by the laws that govern it, unfolding in the only way it can. And in that context, the darkness is no longer unsettling. It is expected, even necessary, because without it, the structures you see, the stars, the galaxies, would not stand out, would not exist in the way they do. And so the darkness becomes part of the balance, not a balance between equal forces, but a balance between the temporary and the permanent, the localized and the universal, the fleeting and the enduring. And when you look up at the sky with that understanding, something changes. The contrast between light and dark no longer feels like a conflict. It feels like a relationship, one that defines the universe at every level, and one that continues quietly, steadily, whether you are aware of it or not. And in that awareness, there is a kind of peace, a recognition that the vastness above you is not something you need to resolve, but something you can simply observe, something that has been there long before you and will remain long after, unchanged in its fundamental nature. A universe where light appears, fades, and disappears, while the darkness remains, constant, silent, and complete. There is a way this realization settles into you, not all at once, not like a sudden revelation, but like something slowly dissolving into the background of your thoughts, becoming quieter, softer, easier to hold. Because at first, the idea that the universe is overwhelmingly dark can feel heavy, almost unsettling. It challenges everything your instincts expect. It reshapes how you interpret something as familiar as the night sky. But as you sit with it, something changes. The sharp edges begin to fade. The discomfort softens. And what remains is not tension, but clarity. Because the darkness is not pressing against you. It is not closing in. It is simply there, vast and indifferent, existing on scales so large that they do not intersect with your immediate experience. And this creates a strange contrast between the enormity of the universe and the small, quiet space you occupy within it. Because here, where you are, there is light, there is warmth, there is structure, and that local experience remains unchanged, even as the larger reality extends far beyond it. And this contrast does not diminish either side. It allows them to coexist. The immense darkness of the cosmos and the small regions of light within it, each defining the other, each giving meaning to the other. And when you allow that coexistence to settle in, the universe begins to feel less like something overwhelming and more like something balanced in its own way. Not balanced in equal parts, but balanced in structure, where the vastness of emptiness makes the presence of light more distinct, more noticeable, more meaningful. And this is where the harshness of the truth begins to transform into something quieter, something easier to carry. Because it is no longer just about the dominance of darkness. It is about understanding the relationship between what is rare and what is common, what is temporary and what is enduring. And once that understanding becomes part of how you see things, the night sky loses its sense of contradiction and becomes something consistent, something that reflects exactly what the universe is, without needing to be interpreted as anything else. Beneath all the motion, all the expansion, all the burning stars and drifting galaxies, there is a kind of stillness that defines the universe at its deepest level. Not a stillness of inactivity, but a stillness of inevitability. A sense that everything is unfolding according to patterns that do not rush, do not hesitate, do not change direction. And this stillness is what the darkness represents most clearly, because the darkness does not flicker. It does not fluctuate in the way light does. It does not appear and disappear. It simply persists, stretching across space and time, unchanged in its fundamental nature. And this persistence gives it a different kind of presence, one that is easy to overlook because it is so constant. But once you notice it, it becomes difficult to ignore because it is everywhere, not just between the stars, but within the very structure of the universe, in the spaces between particles, between objects, between moments. And this creates a sense that the darkness is not something separate from everything else, but something underlying it, something that remains when all other processes are stripped away. And this is where the universe feels the most quiet, not empty in a way that suggests absence, but quiet in a way that suggests completeness, as if everything that needs to happen is already happening, unfolding across scales far beyond immediate perception. And this quiet does not demand attention. It does not ask to be understood. It simply exists. And when you allow yourself to sit with that idea, to let your thoughts slow down and match that stillness, something shifts. The need to resolve the darkness, to explain it fully, begins to fade, replaced by a kind of acceptance that does not require answers, only awareness. And in that awareness, the universe feels less like a problem to solve and more like a space to experience, vast, quiet, and unchanging in the ways that matter most, where the darkness is not an interruption, but the foundation upon which everything else rests. At the end of all explanations, after the physics, the scale, the time, and the structure, there is something that remains, something that cannot be reduced to equations or models, something that stays with you long after the reasoning is complete. And that is the simple, quiet realization that the universe is exactly as it appears, not in detail, not in every complexity, but in its most fundamental expression. The darkness you see is real, not an illusion, not a limitation of your senses, but a direct reflection of how reality is built. And this realization carries a kind of stillness with it, because it removes the tension between expectation and observation. It replaces the question of why the sky is dark with an understanding that it could not be otherwise, given the way the universe is structured. And once that understanding settles, something else becomes clear. The darkness is not something you need to interpret as negative. It does not imply emptiness in a way that diminishes meaning. It simply reflects the scale and nature of the cosmos, a scale where light is rare, where structure is localized, where time stretches beyond intuition, and where most of what exists does so quietly without illumination. And in that context, the presence of light becomes something different, not something that defines the universe, but something that stands out within it, something that gains significance precisely because it is not the default. And this shifts the way you relate to what you see. Because the stars are no longer competing with the darkness, they are existing within it, small, temporary points of brightness in a vast, enduring field. And that field, the darkness, is not empty of meaning. It is simply not expressed in the way your senses are designed to detect. And when you allow that idea to settle, the need to resolve the contrast between light and dark fades, replaced by a sense that both are part of the same system, one that does not favor one over the other, but simply unfolds according to its own rules. And in that unfolding, the darkness remains constant, not as an absence, but as a presence that quietly defines the boundaries of everything else. Now, as everything begins to slow, as the ideas gently settle and the questions soften into something quieter, there is nothing left to solve, yet nothing left to figure out, only the experience of being here, in this moment, under a sky that no longer feels simple, but no longer needs to be understood in the same way, because you have already seen what it was trying to show you, not through effort, not through force, but through a gradual unfolding, one layer at a time. And now what remains is something softer, something easier to hold, the sense of space, of distance, of stillness, stretching far beyond anything you can reach, and yet not pressing against you, not demanding anything from you, simply existing, vast and quiet, while you remain here, in a small, warm pocket of light, surrounded by something much larger. And as you let that thought drift, the contrast between light and darkness begins to feel less like a division and more like a rhythm, something that moves naturally, without tension, without urgency, and your awareness can begin to follow that rhythm, slowing down, letting go of the need to hold on to every detail, every idea, allowing them to fade gently into the background, just as light fades into darkness across the universe, not disappearing, but becoming part of something wider, something quieter. And as you rest in that feeling, the scale of the cosmos no longer feels overwhelming. It feels distant, calm, almost weightless, and your thoughts can begin to soften, to drift, to move more slowly, as if they are following the same gentle expansion that shapes the universe itself, stretching outward, then settling, becoming quieter with each moment. And there is nothing you need to do, nothing you need to hold on to, just the steady awareness of space, of stillness, of the quiet presence of a universe that continues unfolding far beyond this moment, while you remain here, safe, still, and at ease. And as the darkness above becomes less of a question and more of a quiet backdrop, you can allow your mind to follow it, not into emptiness, but into rest, into calm, into a gentle sense of drifting, where the boundaries of thought begin to fade, and the only thing that remains is the quiet, steady presence of the moment itself. If this journey through the quiet darkness of the universe helped your mind slow down, even just a little, then you can simply stay here for a moment longer, letting that stillness settle in. There's nothing left to solve, nothing left to figure out, only space, distance, and the gentle rhythm of a universe that continues without urgency. And maybe tonight, and as you drift closer to sleep, the night sky won't feel empty anymore. Maybe it will feel calm, vast but not overwhelming, silent but not lonely. Just a quiet reminder that not everything needs to be filled to have meaning. If you found comfort in this kind of slow exploration, you can leave a like so this video can reach others who might need the same peaceful moment. And if you'd like to continue exploring the universe in this calm, thoughtful way, you're always welcome here. For now, just relax, let your thoughts drift, and gently follow the darkness into rest.